Let's look at some work here on coordinates and scatterplots. Let's talk about what they are. First off, we're going to start with some scatterplots, and then we'll get into coordinates on a graph. Here's a scatter plot. This would be the men's 5,000 meter gold medal times at the Olympic Games, and it looks like somewhere about 1908. I think 1908 is the first time they ran the 5,000 meter. And if you are not familiar with how far a meter is, 5,000 meters is approximately 3.1 miles. So you see the years down at the bottom, and along the side is the time, and that's in minutes. Then 1908, the first one was somewhere around 1438. I could be off on that being 1908 because this is 1920, and I'm thinking that's 1920, so maybe this is 1916 because the Olympics go every 4 years. The Summer Olympics do. The Winter Olympics go every 4 years too. It's just they're on opposite years as the Summer Olympics. So if we're looking there, and you notice that the trend is that the times have come down, and you notice there's a kind of a gap here. That would be 1940, 1944. You would probably recognize that as the years in which World War II was happening, and I don't believe that there was enough men to fill the Olympic Games, so they canceled them those 2 years. But if we keep watching, the times, I mean, from here to here is a pretty significant drop, but then they kind of stayed around in that area for a few years. This one went up. So what would you think would be happening here? Do you think times would keep going down, or do you think times would kind of level out, something like this, or do you think times would keep coming down? For a long time, it was thought that a person could not run a mile in faster than 4 minutes, but Roger Bannister was the first person to do that, and he ran, it was just under 4 minutes. And so what's happening here? Is there a limit on how fast humans can run? Well, let's look at the rest of the scatter plot throughout the years, and we see this trend. And so now we're noticing that it's a downward trend. Over the years, the times are going down. And this is what scatter plots are useful for. They're useful for checking out, data and determining trends. It's one use for scatter plots. Now, if the Olympic Committee, noticed the time this year, and then the next year, instead of it being here, it dropped way down here, and then it went way up here, and then it continued on this. But this one right here was way down. They may want to, consider checking into that. There might have been some foul play going on. You never know. And that's one use that they could have looked at a scatter plot for. I would say that this gentleman right here that ran a 12:57 for the 5,000 meter, I would say that he was moving pretty quick. But even any of those other Olympic medal times, those are all under 15 minutes. That's really fast. Let's look here. I have a scatter plot. This is home runs hit each season by 3 different home run hitters. Babe Ruth was the first one, and he played somewhere about 1916 to 1938, it looks like. Hank Aaron. Babe Ruth has the 3rd most home runs hit in a career. Hank Aaron has the 2nd most home runs hit in a career, and he played somewhere about 55 to 78. And Barry Bonds has the 3rd most home runs hit in his career. And if you notice, there are some trends. We can look. Babe Ruth, his home run totals were low First 3 years of his career, he was a pitcher. And if you notice the trend, they go, actually, they don't go up like that. They go up here, here, and then they come down here a little bit. Something like that. Hank Aaron's are kind of all scattered. And there are some dips. I mean, there are some dips like right here in the middle of his career. There could have been an injury. Babe Ruth had the same thing. There could have been an injury there, and that's the reason why they didn't hit as many. And Barry Bonds, kind of the same thing. And I would say that, well, it doesn't go down to there because we have, let's see, we have these ones here, and then this one way up here. And then they went down. This one went way down and up here, and there was an injury there. I do remember that season for Barry. But this one that's way up here, I mean, that one's pretty far out there. That is the single season home run record in Major League Baseball is at 73. Mark McGwire, I think the year before this, this year, Mark McGwire, a different home run hitter, he hit 70, and then the next year Barry Bonds passed it. So scatter plots can be used to look at trends, and you might say that a lot of people think that Barry Bonds was on steroids, and there's a possibility, and I think there's even some evidence that proves that. But you want to look at these trends, and maybe you want to compare who's the greatest home run hitter, and they all played in different eras, so it's hard to compare. But if we look at all the data together, and I know that's a lot of data that's together, but look over here at the key. Barry Bonds is in blue, Babe Ruth in red, and Hank Aaron in the green triangle. What I've compared was the first year of their careers, the second year of their careers, the third years, fourth years, and you can compare what's happening. And you notice these first 4 years, Babe Ruth started out low in home runs. Remember, he was the pitcher. And then they all started going up. And then they all came back down towards the end of their careers. So, in actuality, I mean, if you look here, I mean, you can look at the data and determine which one you think's the greatest home run hitter. Other than this one that's way up here for Barry Bonds, they all tend to follow the same pattern. They went up to the peaks of their careers, and then at the beginning and the ends, they were either on their way up or on their way down. So this is one way to look at some scatter plots as some real life data here. I'll leave that up there for a minute. If you want to pause the video and look at it a little bit longer, you can do that. I'm going to go ahead and move on now. This is a coordinate plane. This whole thing is a coordinate plane. So if you want to title that as the coordinate plane, I have 4 kind of like vocabulary terms there for you. The x-axis is this axis right here. It's the white line. And typically you will see an X at the end of that white line when you go to graph points, but you won't always. Sometimes you don't. The y-axis is this white line. That's the vertical line that goes through the point 0, 0. That's called the y-axis. And just like the x-axis, you do see a y there for the y-axis. The origin is this point right there. That would be the point 0, 0. And the last one, an ordered pair. An ordered pair, like say, if we had this point right here, 1, 2, 3, 4 to the right, and 1, 2, 3 down. This is an ordered pair, which you see in parentheses. That's how you name a point. So that's kind of just a quick description of the definitions that we will be using. That's like a visual definition, I guess. I'm going to move to the next page. So you might want to pause the video. Coordinate plane represents the whole thing. Okay, so we have two parts here. We have 4 points plotted there on the graph, on the coordinate plane there, and we're going to match the ordered pairs with them. We also have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We're supposed to move those into the quadrants. So let's look. Quadrant 1 is this quadrant. And quadrant 1 is that fourth of the graph. Now, what point is in quadrant 1? Well, you name these, okay? You name these. The x-coordinate goes first, and the y-coordinate goes second. So this point right here that we're talking about, how far along the x-axis is it? Now, remember, this is positive 1, positive 2, positive 3. This is negative 1, negative 2, negative 3, negative 4, and negative 5. And this is the same way with the y's. 1, 2, 3. Positive numbers go up. Negative 1, negative 2, negative 3, negative 4. Negative numbers go down. So the point we're working with, the x value is 4. The y value, you go up 1. So you went to the right 4, and you went up 1. Now your quadrants are named counterclockwise. This is quadrant 2. This is quadrant 3. And this is quadrant 4. And quadrants or Roman numerals are used to name those quadrants. So let's look at the point in quadrant 2. Quadrant 2. What's the x value? Remember, this is the x-axis, so you should choose the x value first. And that point is right above negative 3 on the x-axis, and it is right beside positive 2 on the y-axis. So you went left 3, you went to negative 3, and then you went up 2 to get to that point. Negative 3, positive 2. Let's look at the third quadrant. This point is below negative 2, and it is beside negative 3. So if you look there, that point is right here. Negative 2, negative 3. And let's look at the point in quadrant 4. Point there in quadrant 4. That's below positive 3 on the x-axis. So you went to the right 3, and you went down 1, and down 1 meant negative 1. And it looks like when I made my ordered pair, I forgot a negative sign there. So that's why I'm going to just go ahead and push it out of the way. So 3, negative 1 is the ordered pair for a point in quadrant 4. You always put the x value first, and then you put the y value second, just like in the alphabet. X comes before y. And then once you start moving into 3D graphing, which is not in the class that you're in, but you also have a z coordinate, which is after both the x and y. It's kind of like alphabetical. Or it's not kind of like alphabetical, I guess it is. So I'd like you to try this one on your own. Plot the points. You may need to draw a little graph. Plot the points, and then label the quadrant or axis of each point. If a point is here, you don't want to say it's in quadrant 2 or it's in quadrant 3. You just want to say it's on the x-axis. That's what you say. It's on the x-axis. And if a point was here, you would say that it's on the origin. That's what you would say. So keep that in mind. So pause the video when you're finished, hit play, and then check it to make sure it matches with mine. All right, the first one, A, is 9, 3. So you go to you always start at the origin. You go to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you go up 3. And you put your point, and you want to label it as letter A. We have A done. Letter B, you go back to the origin and you start there. And -2. -2, remember we're going on the x-axis first. You go left 2, and then up and down 0. And you want to label that letter B. Letter B is good. Letter C, you start at the origin, and you go to the right 7 on the x-axis. And then you're going to go -6, which means you go down 6. And it gets labeled letter C. Letter D, start at the origin. -4 on the x-axis, so 1, 2, 3, there's -4, and -3 on the y-axis, 1, 2, 3. That's letter D. Letter E, there's the origin. You always start at the origin. You go -8 on the x-axis, 1, 2, 3, 4, 5, 6, 7, 8. And then you go +5 on the y. And there's that one. Letter E. Letter F is right there. That's letter F. Now it says label the quadrant or axis of each point. Okay? Letter A is right here. Letter A is in quadrant 1. Letter B is right here, and it would be on the x-axis. Letter C is down here, and it is in quadrant, well, if this is 1, counterclockwise, 2, 3, 4. Letter C is in quadrant 4. That would be I and then V. Letter D is in 3. Letter E would be in 2. And letter F is the origin. So, well, that's all we have for coordinates and scatter plots. We will see you in the next video. It's been a pleasure.